Okay. Hey kids, welcome to Math in Mrs. P's Kitchen. I am lucky I got a giant dry erase board in my house, so we get to do some SAT prep. Hopefully you're making the most of your coronavirus days, and if you get bored, I can give you as much SAT prep as you would like. But I wanted to go over the question that I'm getting the most questions about, which is number 15 on part A. So here we go. It says, when the complex number a plus bi is multiplied by I, the product is 9. So I'm going to stop there, and I'm going to do exactly what it says. A plus bi is multiplied by I, and the product's equal to 9. So we're going to distribute the I. Got ai plus bi squared is equal to 9. Now we know I squared has a value of -1, so I'd rather not have to look at i's, and I'm going to go ahead and make that substitution. ai plus b times -1 equals 9, and simplifying further, we have ai minus b is equal to 9. Now I think this is where the less obvious step actually occurs. By this equation, we actually know the values of both a and b, which is going to help tremendously in figuring out our ultimate goal, the value of ab plus b squared. So we know ai represents an imaginary piece because we still have that I there. Problem is, we have no imaginary piece on this side with the 9, which really means we have 0 i's. We have 0 imaginary pieces, which then tells us that a has got to equal 0. Now we know -b represents a real piece because there's no i's involved, and obviously 9 is a real number, which means -b has to equal 9, or b has to equal -9. Like I said previously, now that we know the values of a and b, we can substitute those into ab plus b squared and come up with our final answer. So I'm not even going to worry about this one, because if a is 0, then 0 times anything is 0, gone. We know that b is equal to -9, and if I square that, there's my final answer of 81. ab plus b squared has got to equal 81. Hopefully that helps. Any other questions you have, feel free to shout out to me, and I would be happy to keep doing math in my kitchen. See you later, kids.